Good morning, everyone. Today, in this session, we are going to discuss another algorithm that is called as the random forest algorithm. So, before going to the random forest, just I want to introduce one concept called as the ensemble method. So, what do you mean by this ensemble method? And what is it just basic idea implementing the ensemble methods for machine learning algorithms? Basic idea behind this ensemble method is rather than just training one model to predict the data with low error, we can try learning multiple models and the subsets of the data and combine them to get overall lower error than possible from a single model. Instead of implementing a single model, classification model or regression model, whatever it may be, training with one model, just we are going to try learning multiple models. That is what the method called as the ensemble method. So this acts as a regularizer because it forces the model to learn a more general solution. And here, the very important note regarding these ensemble methods are more general than decision trees, and they can be used for any classifier, but generally they go particularly well with the decision tree. Instead of constructing one single decision tree, we can try with implementing multiple decision trees. So that multiple decision trees, generally we call it as a random forest algorithm. It is a popular machine learning algorithm that belongs to a supervised learning technique, and it can be used for both classification and regression problems. It is based on the concept of ensemble learning, which is a process of combining multiple classifiers to solve a complex problem and to improve the performance of a model. As the name suggests, it is a classifier that contains a number of decision trees. This is an important point regarding its random forest. It contains number of decision trees on various subsets of the given data set, and it takes the average to improve the predictive accuracy of the data set. That is, finally, what it is instead of relying on one decision tree, random forest takes the prediction from each tree, and based on the majority of the votes of prediction, it predicts the final outcome. And the greater number of trees in the forest leads to higher accuracy and prevents the problem of overfitting. We already discussed that some of the limitations or disadvantages what is the decision tree is. If the number of trees increases, there is a chances of overfitting in decision tree. So to overcome that problem, we are going to use this random forest where the number of trees in the forest leads to higher accuracy. This is one advantage, and it is going to overcome the problem of overfitting. And one of the most features of this random forest is it can handle the dataset that contains both the continuous variables in case of regression and categorical variables as in the case of classification. This is one important feature of this random forest algorithm. Coming to the working of this random forest algorithm, as we already told you, it is an ensemble learning or ensemble method. Random forest is an ensemble method or ensemble learning. Okay. And it uses two types of methods that is called as bagging, and another method is called as the boosting. So by seeing this picture, we can identify this is parallelly, it is each tree is going to get one outcome and majority of voting gives the final outcome. But here, when you see the boosting, the output of one tree may be an input of other tree, and this output of other tree will be input of the other tree. This is a sequential that is called as the boosting, bagging and boosting. Let us discuss what is this bagging. It is also known as the bootstrap aggregation, and it serves as an ensemble technique in the random forest algorithm. And these are the few of the steps involved in bagging. The very first step is selection of subset. That is, from the given data set, we have to select a sample or subset from the entire data set. So bagging, the very first step itself starts by choosing a random sample or subset from entire data set. Then bootstrap sample. Each model is then created. Each model is created from these samples that we call it as a bootstrap samples, which are taken from the original data set with replacement. So that's why this process is called as the row sampling. Original data only we are taking some samples, but with some replacement. That's why this process is called as the row sampling. Then coming to the bootstrapping, the step of row sampling with this replacement is referred to as the bootstrapping. Why the name this bagging is also called as bootstrap is This what we are doing in the second step, row sampling with replacement, it is referred to as the bootstrapping. And the fourth step is independent model training. Each model is trained independently on its corresponding bootstrap sample. We have divided it into sample. So each model is trained on that sample. And this training process generates the results for each model. Next one is majority voting. So the final output is determined by combining the results of all models through majority voting. Suppose you have constructed 4 decision trees. Each decision tree will give you one outcome, and majority of that outcome is going to taken as the final output. Last one is aggregation. This step, which involves combining all the results and generating the final output based on the majority voting, or what I said earlier, that process generally we call it as the aggregation. So the total, these 6 steps are given in this diagram. You can see here once. This is the original data. This original data is being given to each tree or each classifier with sample data. These are the samples of the data. And that is called as a bootstrapping. And each classifier will give you one result that is called as the aggregation. And finally, we combine all this is to form an ensemble classifier, and that process is called as the BAG. This is how a random forest algorithm works with this BAG. This is how the process goes in BAG. So you can see here the bagging ensemble method. This is the actual data. This is bootstrap sample 1, sample 2, sample 3. And for each one, we'll construct one model. And when you see this model has given this smiley, this model has given this smiley, and this model has given this smiley. So out of 3, the majority classifiers has given this one. So the output will be this one. This is a majority voting. This is the concept behind this majority voting. Then the next method of this ensemble is boosting. So boosting is also one of the technique that uses the concept of ensemble learning, and it combines multiple simple models. Generally, we call that simple models as also a weak learners to generate the final output. When there are weak learners are there, then we can combine that to make it one strong one. It is done by building a model by using weak model in series. There are several boosting algorithms. In that, the very one famous algorithm and successful algorithm was the AdaBoost that was developed for the purpose of binary classification. And this AdaBoost is an abbreviation for this adaptive boosting. And it is a boosting technique that combines multiple weak classifiers into a single strong classifier. This is a important point, students. What is this AdaBoost? Is nothing but it combines multiple weak classifiers, and it is going to give us a single strong classifier. That is what the concept behind this AdaBoost. And coming to steps involved in this random forest algorithm, the very first step is a subset of the data points and subset of features is selected for constructing each decision tree. Why? Because in random forest, we'll have n number of decision trees. For that, we are going to divide the subset of data points and subset of features. And simply put, we can say that n random records and m features are taken from the data set having k number of records. Okay, so this is what is this first step 1. And then the step 2 comes, individual decision trees are constructed for each sample. Here, whatever the sample we have taken up, for each sample, we are going to construct each individual decision tree. And each individual decision will generate an output. And the final output is considered based on the majority voting or averaging for classification and regression respectively. So for classification, we take the concept of majority voting. And for regression, we'll use a concept of average. So these are the steps involved in random forest. So the same example, we have training a bunch of fruits to a model, and we have constructed first a decision tree 1, and we have given some output. It has given the output as class A, that is, it is an apple. And we have some subset of data we have given, and we have constructed another decision tree, and it also resulted us with output of class A, that is apple. Likewise, we have constructed, and the last one decision tree, the same sample of data it has taken from this one, it has given the output as class B, that is banana. So when we see all these things, majority vote says that it belongs to class A, that is all. That is a apple. So we are going to take the decision that particular input it is predicting is the apple. In this way, the random forest ensemble method is going to work. Important features or the characteristic of this random forest is diversity. That is, not all attributes or variables or features are considered while making an individual tree, and each tree is different. So as we are constructing n number of trees, each tree won't have the same variables or features. Okay, while we are making the individual tree. And the second important point is it is immune to the curse of dimensionality. That is, as we are not considering all the features, so the feature space is reduced. That is, there is a dimensionality reduction of the features. So when we have a reduction in dimensionality, chances are there that we'll get the more predicted accuracy. Then parallelization. Each tree is created independently out of different data and attributes. That means we are fully using the CPU to build the random forest. Train test split for every algorithm. So in a random forest, we need not to have to segregate data for training and testing. Why? Because as always, there will be a 30% of the data which is not seen by the decision tree. And stability, when the stability arises is when the result is based on the majority voting or average. The stability is definitely it will arise based on the results of majority voting or averaging. These are some of the important features regarding to this random forest. And coming to this difference between decision tree and random forest, we know that random forest is a collection of decision tree, but still there are some differences between when we talk about the behavior of decision tree and random forest, there are some differences. The very first is decision tree normally suffers from the problem of overfitting when it want to grow without any control. If the tree is been growing, yes, chances are there that it may overfit the data. But as random forests are created from the subsets of the data and the final output is based on averaging or majority ranking, hence the problem of this overfitting is taken care of. And a single decision is faster, but it is comparatively slower. Why? Because we are constructing n number of decision trees. And when a data set with features is taken as input by decision tree, generally it will formulate some rules to make the prediction, which we have seen in the earlier example when we discussed the decision tree. But as random forest randomly select observations and builds a decision tree and as taking the average result, it does not use any set of formulas. Why? Because it is using the majority voting or averaging. So it need not to frame any rules. But decision tree, as it's single it's constructing, it has to form the rules to make the predictions. So these are some of the difference between decision tree and the random forest. And coming to the applications, real-time applications where we are going to use this random forest is, the very first one is customer churn prediction. Business people can use this random forest to predict which customers are likely to churn. That is when they're trying to cancel their service so that they can take steps to retain them. Fraud detection. Okay. A bank might employ a random forest model to spot transaction from unusual locations or large amounts of money, where we are going to detect some of the frauds. And the next one is a stock price prediction. Medical diagnosis, it helps the doctors to diagnose some of the diseases, okay, whether how to help them diagnose a patient with cancer or some other diseases. And then the image recognition, you can recognize objects in images, like a self-driving car might use a random forest model to identify the pedestrians or other vehicles on the road, so that taking care of not to happen the accidents. So these are some of the real-time applications of this random forest. Thank you.